Alright, in this video we are going to learn how to write the rate law and how to find the order of a chemical reaction. But first, what is the rate law? Rate law is the correlation between the rate of a chemical reaction and the reactant concentration. For example, for a reaction such as A that gives products, the rate is given in general, K that is the constant of proportionality, concentration of A, and N that is the order with respect to A. Keep in mind that the order of a reaction can be determined only experimentally. That's why this is N and this is A, because this is not the coefficient of the balanced equation. This is a number that is going to be founded experimentally. There are three common reaction orders. The first one are zero order reaction, n equal to 0. So the rate is going to be K multiplied by the concentration of A to power 0, because it's this n here. So we know that each number to power 0 is going to give 1. So the rate is directly proportional to the constant. So from this plot here, the rate and the concentration of A, we see that zero order reactions are independent of the concentration of the reactant. So it's going to be this line here. Rate is going to be equal to K. Let's move now to the first order reaction. So it's going to be n equal to 1. So the rate is going to be K multiplied by concentration of A to power 1. So it's going to be proportional to the concentration of the reactant. So it's going to be linear. So it's going to be this one. Rate is going to be K multiplied by the concentration of A to power 1. We have also the second order reaction, so n equal to 2. So the rate is going to be this time K multiplied by the concentration of A to power 2. So it's going to be proportional rate with the square of the concentration of the reactant. So it's going to be this line here. Rate K A power 2. A common way to determine the reaction order is the method of initial rates. In this method, the initial rate, the rate of a short period of time at the beginning of the reaction, is measured by running the reaction several times with different initial concentrations of the reactant to determine the effect of the concentration on the rate. To demonstrate this, we are going to see this example. Write the rate law and calculate the value of the rate constant for the reaction below by using the given data. What is the overall order of the reaction? Keep in mind that all these rates are measured experimentally. So what we are going to do? This is the balanced equation. First, we are going to write the general rate law, that is this one. Be careful, this m again and this n are not the coefficient on the balanced equation. They are determined experimentally. They determine the order with respect to a, m, and with respect to b, n. Be careful, do not place. Sometimes, by coincidence, may happen that they are the same with the balanced equation, but it's just a coincidence. It's not like they are like that all the time. So we have the initial rates in the table. What we are going to do? We are going to keep one reactant constant in concentration and to be able to simplify and to make calculation for the other reactant. As you can see here, we have two pairs of rates. We have, in order to find A, we have to take rate 2 divided by rate 1 in order to keep the B constant, okay? And if we want to find the B order, the order with respect to B, we are going to keep rate 3 and rate 2 constant, and we calculate by the change in the B. So what do we have? First, in order to find the order for the A, it's going to be rate these are equal to the initial rates, to the corresponding initial rates. So it's 0.051. So what we have here? This one simplifies. 1 to power everything is equal to 1. Constants are going to be simplified. So it remains only If we divide this once, it's going to give us 1.96, approximately 2. And if we divide this one, it's going to give 2 to power m equal to 2. So obviously the value of m is equal to 1. So at this point, we found that the order with respect to A of this reaction is 1. So rate is going to be K power A to power 1. Now we are going to find for B. For B, we are going to take ratio of rate 3 with rate 2. So again here, this simplifies, in this case, simplifies for the A. So we need the B, we need the N. And here we are going to divide this one. So we have again 0.2 divided by 0.1 is going to give 2 to power n equal to 2 if we divide this one. So n is going to be 1 in order for this to be equal. So again, we found that the order with respect to B is 1. What we need to find? We need to find the overall order. The overall order is order 2, second order. We sum this one with this one. Okay? As you can see, this numbers does not correspond to the coefficients. This is 1 here. It's not right because it's 1. Doesn't correspond to the coefficients. So don't make the mistake to put the coefficients in the reaction order. It's different. Now we need to find also the constant. The rate constant. The rate constant is simple. We can take any rate that you want, rate 1, rate 2, rate 3, rate 4, etc. And we are going to place to the general rate law to find the constant, because we know the initial rate, we know the order, we know the concentration. We need to find the K. So what we are going to have, K is going to be equal to rate divided by what? Divided by the concentration of A to power 1 with concentration of B to power 1. So if we take the initial rate 1, we are going to take also the initial concentration for rate 1. So don't confuse the concentrations. So it's going to be 0.026 mole per second divided by 0.1 molar multiplied by 0.1 molar. So from here we can find that this is equal to 2.6. Now molar to molar is molar square, simplified with this one, and is going to be molar minus 1 to second minus 1. What we found also here, we found that the constant for the second order reaction is molar minus 1, second minus 1. You do not need to remind this one, but you need to remind only this general formula. So for any order of the reaction, molarity is 1 minus n divided or multiplied by second minus 1. For example, if the reaction is zero order, like n is equal to 0, so the unit of the constant is going to be molarity 1 to power 1, because n is equal to 0, multiplied by second minus 1. That makes sense because the rate is equal to the constant, and we know that the rate is molarity per second, and the constant for zero order reaction is, because at zero order reaction it's independent of the concentration of the reactant, the rate. So it's going to be molarity per second. And if you want for the first order, it's simple. Just place 1 to the n here, and you have molarity 1 minus 1 times seconds to minus 1. So this is 0, and it's going to be second minus 1 for the first order reaction. Alright, hope it was clear a little bit to determine the order of the reaction. And thank you so much for watching, and see you in the next video. Peace.